Here I will show you how to generate random numbers according to the typical distributions that we use in statistics. So we'll be doing that in R. I'll be using Python as my IDE. Python is a new IDE that allows me to code in both R and Python. And the idea is that I can put my code into panels and then execute those panels either individually or connect them to each other and run my code in a more interesting way. So you can download Python from the following website, www.python.com. It is available only for Windows right now. You would probably want to download my project distribution.python from the following GitHub repo over here. And what I will be doing here is pretty simple. I will be putting my code into these panels and then executing them. And I will show you how we can generate random numbers according to the normal distribution, the Gaussian one, the beta distribution, the gamma distribution, and then the t-student. So there are other ones, but these are the four most used ones. So one thing here is that I mentioned we can put our code into panels. We can obviously have different panels. So here I can choose if I want R or Python, and then I can connect them like this. And then, for example, I could run these two panels because they are connected. For example, I could do print t, for example, as a simple example, and I can run this in a way that both of them run. So let me explain that. So if we click here and run only this one runs only this panel like this, which gives me what I had before. If I run up to here, it will run all the panels that are connected into the in part, so all the panels that feed variables and objects into here, but here I don't have any, so that won't make any impact. It would be the same as running just that one. And if I run below, if I click here, this means this panel runs and then this one runs. So let's see what happens. As you can see, this panel ran and then this panel also ran. Obviously not very useful, but just illustrates the idea. Anyway, so I have my coding here. I will be using ggplot for the plots. This is a very simple function. So ggplot, we call the data frame that we want to use, and then we specify the columns that we want to use. Here I use the cut function in order to produce this nice palette of colors ranging from orange to purple. And I'm specifying, remember to put show.legend equal to false, because if not, something horrible will appear here. A nice thing about Python is that the plots that we create either in ggplot or plot, or even if we use Python and we use matplotlib and things like that, they get loaded next to a panel that generated them. So that's pretty cool. So the Gaussian distribution is pretty simple. It's a symmetric one centered around a mean. So here it's implicit, but what R is doing, R is assuming we have something like that. We can, for example, let's just assume we have something like that, and we just run again. So the shape of this will obviously change. So that's the Gaussian distribution. Then the beta distribution is quite important because it generates random values between 0 and 1, but with these strange shapes, and they are governed by two parameters that we have here. So I plotted two examples, 1 and 2 and 5 and 2, and you can see how completely different the histogram looks like. The same happens for the gamma distribution, which has two parameters, but now the support is not between 0 and 1, it's between 0 and plus infinity. So depending on which value we use, we get very different results, as you can see here. And finally, the t-student distribution, which is obviously very famous, and only has one parameter, the degrees of freedom. So if we use, for example, a low amount for the degrees of freedom, 2 for example, we get a weird shape like this, so everything gets concentrated into just one value. And if we use, for example, 100 degrees of freedom, this starts to look quite similar to a Gaussian distribution, which kind of makes sense. You probably know or heard about many statistical results that say that as the number of degrees of freedom increase for the t-student distribution, that distribution behaves very similarly to a Gaussian one, which is what we have here. One nice thing that we can do in Python is that we can freeze the results of the panels and then we can compare them. So let me show you how that looks like. So let's suppose we create a new panel in here, and we we just simply generate these student values, and then we do the standard deviation of D. We run that, which here we have an issue. This is a data frame, so this should be d.x, and that should be fine. So there the standard deviation is 23. So you may be wondering, what happens if we change the degrees of freedom and want to see the standard deviation? So instead of me needing to remember it's 23, one thing I can do here is to freeze the log or the output. So it got frozen in here, and now I can rerun this with a different value. Let's just put 5,000. Let's run it again. So as you can see, it appeared here. So now the standard deviation got really small, from 23 up to 1, so quite a big difference. But the nice thing is that instead of me needing to remember the results, I just compare them like that. And I can freeze as many times as I want, obviously.